All right, good morning and welcome back. Today we are going to be working on 7.3, okay, sum and difference identities. So if you pull out that orange sheet, your unit circle, if you flip to the back here, yesterday we talked about even and odd identities and Pythagorean identities. We also talked some about how to simplify our original trig identities. So today we are going to go to sum and difference identities. And this occurs when we have multiple angles. We're trying to find the sum of the two angles sine, or the sum of the two angles cosine, or the difference. Okay, or we can go to tangent, although today we're only going to talk about sine and cosine. So here are your formulas. Make sure you have this handy. You don't have to have these memorized, but you do need to be able to find them quickly so that you can do these problems. So if we look here, what I recommend you do on all of these problems, whether it's sine of a plus b, here's cosine a minus b, cosine a plus b, or sine a minus b, whichever one it is, start by writing just what do you need to know. Okay, so since we're doing sine of a plus b, if we look over here and notice on the back of your sheet, I believe I have alpha and beta instead of A and B. It's the same thing, just your alpha kind of looks like the swirly A, your beta kind of looks like this B, it's got a little tail, but it's the same exact thing as what I have here. So as we look here, we are doing the sine of A plus B on this first problem. So right here, we're just going to copy what we have here. We need to find what the sine of A is, okay, times whatever the cosine of b is. Then we're going to take that plus what is the cosine of a times the sine of b. Now, right now in the information, we are given some information. We're given what sine of a is, 3 over 5, and what tangent of b is, 7 over 24. Okay, so we, in the end, need to find these four pieces of information, and then we can solve and simplify. So over here on the left, I'm going to write sine of a, that will equal cosine of a. We want to know what that equals. We also want to know what sine of b equals and what cosine of b equals. All right. So as we look here, we can start with sine of a. We already have that, 3 over 5. So 3 over 5, we'll put that there. Now cosine of a, to find what cosine of a is, we're going to have to be a little more creative. We have to set up a triangle. So if we think about it, sine of a, we know SOHCAHTOA. If you're having trouble remembering that, maybe write it down at the top. So SOHCAHTOA. So we know sine is O over H. So if we think about this as a triangle, or more specifically a right triangle, if this is angle A, then O, the opposite, would go on the opposite side. That is going to be 3. Our hypotenuse here is 5. Now, you might not know what this missing side is. It's a right angle, so a squared plus b squared equals c squared. Now, in this case, if there's a 3 and our hypotenuse is 5, if we look at the bottom here, we have some common Pythagorean triples. And I think on yours, you don't have this bottom one, 20, 21, 29. Also, if you're ever solving and you get a 3 whole numbers, just write it down on this list because there's more than this. This is just some of the common ones. Okay, so we have a 3, we have a 5. The biggest one always has to be the hypotenuse, so we can know that missing side is 4. If you weren't sure about that, instead you could have used a squared plus b squared equals c squared. So if that's 4, we can put then 4 over 5. Okay, now for the next one, to find b, this one is dealing with tangent. So TOA, O over A. So if we look here, TOA, so I'll draw this triangle. So right triangle, we'll put little b there. Okay, TOA opposites, so 7 over adjacent, that's 24. Now we don't know what our hypotenuse is, so 7 and 24, they're both whole numbers. Let's check our list. Look at that, 7 and 24 right here. If we square both of those, we will get this what 25 squared is. Okay, so we can fill that in. Now, once again, if you don't know that, just use a squared plus b squared equals c squared. That's totally fine. It'll work. It'll get your answer. So we have sine would then be 7 over 25. Meanwhile, cosine would be 24 over 25. Okay, and now all we have to do is fill in each of these slots. So sine of A is 3 over 5 times the cosine of B, 24 over 25. And once again, I know we didn't prove why this works. We're not actually going to in this class. If you go on to calculus, you'll start to look into that. For now, we're just going to accept it. If you'd like to see it, let's talk about that sometime. But for right now, we aren't going to have time to prove that. But cosine of A will be 4 over 5. Sine of B, 7 over 25. Then we multiply across the top and the bottom. So we'll get 72 over 125 plus 28 over 125. Combine your like terms. Or sorry, not combine your like terms. Add. They have a common denominator, so we're good. And if we do this, 72 plus 28 leaves us with 100 over 125. Okay, we can now reduce that. 25 goes in 100 4 times, goes in 25 5 times. And we are done. Okay, so I know that problem took a little bit of time. Okay, if we look at our clock, we're already almost 7 minutes in. These problems do take a little bit of time. The homework only have to do 4 total, and tomorrow's a catch-up day to make up some lost time. So once again, on this next one, this time it's cosine of A minus B. So we look over here, scroll down, cosine of A minus B right here, and we'll need to copy that down. So we know we're going to try to find whatever the cosine of A is times the cosine of B plus whatever the sine of A is times the sine of B. Okay, now, as we said, we need those 4 things. So over here, I'm going to write sine of A. What is that? What is cosine of A? What is the sine of B? What is the cosine of B? If I can find those 4 things, then I will be good to solve. Now, we already have 2 of them. Cosine of A, 21 over 29. So I'm going to go ahead and fill that in. 21 over 29. So that's A over H. So once again, as I draw this right triangle, our A adjacent to this angle, so that's 21, H 29. Okay, now 21, 29, this one, if we go check, I don't know if this one was on yours, but 21 and 29, we have it on mine. So 20, 21, 29, add that to your list. We're missing the 20. Okay, so this one right here will be a 20. That's the opposite, so our sine of A is 20 over 29. And we're done. Now the next one, sine of B, we already have, so 12 over 37. Once again, we'll draw our triangle. It's a right triangle. This is angle B. We have opposite 12 over 37. And we want to find that missing spot. Now here's the deal. This is not on our list. Our list doesn't go this far. But we can still calculate it. We just got to do A squared plus 12 squared equals 37 squared. Now 12 squared, you guys probably know, 144. 37 squared, I don't expect you to have that memorized. Just use your calculator. Save a little time though. It's going to be 1369. We'll subtract 144. Now we'll have A squared equals 1225. And when we take the square root of that, we'll get A to be 35. Now if you want to save your time in the future, you can add 1235. Oops, got to put the pencil on. We could add 35, 37 to our list. If you don't want to do that, you don't have to, but then next time if you get some of those numbers, that'll be there for you. Okay, so now we can fill that in, 35 over 37 for cosine B. We're almost done with this one. So cosine A, 21 over 29 times cosine B was 35 over 37. We'll add that. Sine A, 20 over 29. Sine B was 12 over 37. Now the good thing is both of these will have the same denominator. Okay, if we multiply 21 times 35, 735. You can use a calculator, that's fine. I used a calculator when I did this. I just am saving us a little time. Over 1073 plus then 20 times 12, that'll be 240. And still, once again, 1073. We add those two together, and we'll get 975 divided by 1073. And we are done. We can't simplify. Okay? So that is how we do it. Now, unfortunately, sometimes the numbers are not whole numbers. They're not, I'm going to be like a special right triangle, or they're not going to be Pythagorean triple in that they're not all going to be whole numbers. Okay, so we might have a radical. Like if we look on the back here, we got a square root of 21. If that's the case, we do the same exact thing. Okay, so we're going to start off here. Same thing. This time we're finding cosine of A plus B. So we look over here to our chart, cosine of A plus B right here. So cosine of A times cosine of B minus sine of A times sine of B. Now, we need to find four things. We need our sine of A still, our cosine of A, our sine of B, and our cosine of B. So we look here, and it says that angles A and B are both in quadrant 1. Okay, so we know that's up to the right, so they both will look something like this. That's how we've been drawing our triangles anyway, but we know that everything's going to be positive. Okay, so cosine of A, so this is our A over H, so H is 5, A, the adjacent square root of 21, and we want to know what goes right there where I put the question mark, so we can just set that up, A squared plus B squared. So if we do square root of 21 and we square that, plus question mark squared equals that 5 squared. Okay, that's going to result in 21 plus question mark squared equals 25. So we'll get question mark squared equals 4. So our question mark equals 2. Okay, so I'm going to change that into a 2. And that's kind of messy. Let me fix that. So we know that will be a 2. And now I can fill in some stuff. So I forgot my A here, but for this, it'll be 2 over 5. We already knew our cosine, square root of 21 over 5. Okay, now for the second triangle, cosine of B, we already have. So 7 over 10. The only thing we need is still sine of B. So we need to figure out, once again, that's A over H. We need to figure out what that O is so we can do our SOHCAHTOA. So once again, same situation. We'll draw our triangle, right triangle. This is for B. The A is here, 7. The 10 goes there, right triangle. And I don't know what this is, okay? Now I'm going to do 7 squared plus, I'll put an X this time. X's are easier than question marks, right? So equals 10 squared, 49 plus X squared equals 100. We'll subtract that. We'll get X squared equals 51. So X will equal that square root of 51. So we'll put the square root of 51 on top over 10. Okay, so now all we have to do is we can plug in some stuff. So cosine of A we just found. We already had that, but square root of 21 over 5 times cosine B was 7 over 10 minus sine of A was 2 over 5, sine B square root of 51 over 10. Now we multiply. Remember, since 7 is outside square root, it can't go inside. 7 square root of 21 over 50 minus 2 square root of 51 over 50. They have the same denominator, so we can actually just combine those into one. Numerator on top, all over 50. And 7 and 2 well, 2 does go into 50, but doesn't go into 7, so we can't do anything to reduce. And both 21 and 51 will not reduce any further. So we are done. Okay. I know this is a little lengthy, so if you need to pause the video, take a little breather, that's fine. Example 4, I'm going to go ahead and just do it because we're rolling. So given that sine of A equals 2/3 and the tangent of B equals square root of 57 over 8. Okay, so that'll be O over H, TOA, O over A. Now, once again, we need our sine of A, our cosine of A, we need our sine of B, and our cosine of B. So sine of A we already have, 2 over 3. Now once again it tells us they're both in quadrant 1. We need to find the exact value of sine A minus B. So if we look at our identity sheet, it would be sine of A times cosine of B minus that cosine of A times the sine of B. Okay, so we draw our triangle. And we know this is a 2, this is a 3, letter A. I need to find what is right there. So x squared plus 2 squared gives us 4. I'm going to save some time. 3 squared is 9. Subtract that, so we get x squared equals 5. So x will equal the square root of 5, which means we'll get square root of 5 over 3 here for cosine of A. Okay, our next one, this time they gave us TOA. They gave us the tangent. So that doesn't really help us. It doesn't fill in either of these already, but we can figure them out because if that's angle B, TOA, so we know it is square root of 57, and this will be 8. So if we square those, 8 squared, here, let's actually save some time. So 8 squared is 64, square root of 57 squared is just 57. If we add those, it'll equal c squared. We add that, we get 121. And hopefully you know the square root of 121 is 11. So we found that missing side to be 11. So now square root of 57 over 11 and 8 over 11 are our two answers. All we got to do, we're almost done. I know this lengthy lesson. Hang in there. Sine of A is 2/3 times cosine of B would be 8 over 11 minus our cosine of A is square root of 5 over 3 and our sine of B square root of 57 over 11. We multiply, we'll get 16 over 33 minus, now since they're both in square roots, we can multiply them together. So 5 times 57, that'll give us 285 all over 11. Now 285, some of you might think we can break that apart. Keep in mind 5 and 57 are two prime numbers there when we multiply them. So we'd break it to 5 and 57. There's no pairs though, so we just leave it. Okay, so I made a mistake though. That shouldn't be an 11 on the bottom. That should be a 33 because we have 3 times 11. Remember, when we're multiplying the numerators, when we're multiplying the denominators do not have to be the same. If we're adding or subtracting, we do need them to be the same. So we got a common denominator. All we got to do now, 16 minus the square root of 285, all that over 33, and we are done. So, wow, that was kind of tough. Tough day. Hang in there. There's a few delta math assignments. A few delta math questions on this topic. If you need help, I didn't put a penalty on it. Click to see the solution. If you need any help, reach out. Tomorrow is a work day in class, so we can get caught up hopefully. But hope you guys have a great day, and I'll talk to you later. Bye.